In this video, we're going to be talking about the Roman to integer problem. Now, as you can see on my screen here, there are already a lot of videos that cover that very problem, that very topic. But what's interesting to me is I checked some of them, but none seem to have the solution that I have that I think, just to be very modest here, is just simpler and easier to understand. So let's just jump right into it. Now, Roman numbers have this special quality that they're usually written largest to smallest from left to right. There are some exceptions though, and these exceptions are written here. So I can be placed before v and x. So 1 can be placed before 5 and 10, and that will make it 4 and 9. X can be placed before L and C. C can be placed before D and M. And I think this is the crucial part that will make our solution very, very simple to understand and to write. So let's just jump right into it. So first thing that I do is I write this map here, but then I have to get the length of my Roman number. So length of number is going to be Roman number dot length. Now, the next thing I do is I define my result or sum. That will be the final value I return. And finally, the final thing I have to do is to define a loop that's going to go over every single one of this Roman number and convert that into, an actual integer. Now, a lot of solutions, what they do is they go left to right. And I'm not saying this solution is bad. The solution will get you to the actual, it will be approved. But the point is that I think it makes this whole problem unnecessarily difficult. And let me show you why. So I'm going to be I'll define a for loop that will go from right to left. So I'm going to start with the last number minus 1. Why? Because if I have my Roman number, that's a string. So let's say this number is 18. This is this position here is index 0. This is 1, 2, 3, and 4. So even though the length is 5, the last position is under index 4, and this is the number I have to start my loop with. So I'm going to be starting with the last number, right? And then I'm going to end when, or run it on until I is lesser than 0, or I has to be larger than equal to 0, and then I'm going to decrease my I, my iterator. So now I'm going to name the value I'm currently looking at as just current. And how do I get this value? So I have to retrieve it from my map. So I have to supply this value to my map. Now I know that if I'm looking at this number, I'm starting with I, right? So I have to do Roman to Arabic. Sorry, my accent has failed me. Roman to Arabic, that's my map, and now I want to retrieve a value from it. So the value is Roman number I. So because I'm starting with the last one, with the last number, the this I here will be equal to 4. And since Roman number index 4 is I, so this will become I, and the Roman number to Arabic value I is 1. So my current value is 1. Now, what I also want to do is I want to see what's the value that's on the first value on the left from my current one. So I'm just going to call it previous, and it's going to be Roman to Arabic. And I'm going to get it from the same Roman number, but it's going to be I minus 1. Why minus 1? Because if my current, let's say again, I'm starting with this one, right? I'm starting with index 4. I want to read the value under index 3. So I have to, subtract my index by 1. So I minus 1, that will give me index 3. Roman from index 3 is going to give me I, because this guy here is also an I. And Roman index from I is again 1. So, okay, so now I have my current value, I have my previous value. Now, what I do is I simply add the current value to my result. So whatever the result is, it doesn't matter to me now. I just add my current result to my current value. And that's it. Now, we have to account for those 6 cases where subtraction is used. So as you guys noticed, I hope you noticed, let's say we consider this value, right? So if we start from right, every value from the left is either equal or greater, right? But if we consider this number, this is 14. So I take a look at this v, which represents 5. This value is lesser than 5. What does it mean? Well, it means that I have to subtract my result with the value that's on the left. So if my previous value, the one on the left, is lesser than the current value I'm looking at, then what I have to do, all I have to do, is I have to subtract that previous value from my current result. And also, I want to skip one iteration. Why do I want to skip it? So let's get rid of this this 18 value here, and let's look at 14. So in my first iteration, I take a look at v, right? So current is v, which is 5. Previous is I, which is 1. So result at first is 0. So my result becomes result plus current, which is 0 plus 5. That's 5, right? And then, because my previous value is lesser than my current value, I have to subtract. So I do result minus previous. So that's 5 minus 1 equals 4, because previous is lesser than current. Now, I have to skip the second iteration, as I said before. Why do I have to skip it? Well, let's say I don't skip it. So now my current value is I, which is 1, and then my previous one is X, which doesn't really matter now, but that's what the algorithm does. So if I don't skip this, this iteration, right? I'll be adding my result to my current value. So what I'll be essentially doing is negating whatever happened here. And this will just skew the results. It will just give me an incorrect answer. So I don't want to go over the value that I did subtraction with. I just want to skip it. All right. So now if I skip it and I go to the last number, the current is X, which is 10. The previous doesn't exist because that's the last one we're looking at. So we just do result equals result plus current, which is 4 plus 10. That's 14. Now, let's see if this solution works. It doesn't. Let's see why. Oh yes, it doesn't work because I didn't return my results. So now it should be fine. Boom, works. Now, sure, you can look at this and be like, hey, this solution is slow. Now, I don't know why this is slow, because I have submitted one that was super fast. It's slightly different because this one uses the while loop instead of for, but the principle is the same, as you can see here. I also get my current one, my previous one, do adding, and then subtraction if applicable. And this solution said it was faster than 95% of other solutions. So don't know what's up with that one. Maybe it's just JavaScript or the nature of the JavaScript runtime. But yeah, this is the solution that I think is just way easier to understand, because every single time you always add the current value And then in one case, if the current value is greater than the previous one, you just subtract the previous one. And that's pretty much it. Other solutions that I saw, they were trying to do something different here. And they were what I didn't like. And they were hard coding some values. So for example, a solution that I saw had like, they were hard coding those rules of subtraction, right? So if there was like a IV number, then it was mapped to 4. Or IX, that's 9. It was all hard coded, and I didn't like it because, well, let's think of the unthinkable. Let's imagine that Roman numerals got an upgrade. I know, not likely to happen, but let's just say that you can do something like you can write I am, that's a valid number. That should be 999. Whereas currently you would have to write like a very, very long Roman number that I don't remember now how to do it. But the point is, if an update drops, those people who hard coded their solutions would have to go back to their code and include all other new exceptions. So the guy that hard coded those values into this mapping would have to add I am 999, which I don't think is a good good solution, because good code is code that needs as little maintenance as possible, and unexpected updates just happen in real life. That's just a given. Other thing that I didn't like, that's also kind of hard coding, was there was one solution where when the guy wrote out those subtraction rules here explicitly, right? So he would do something like, if the current value is V, or if the current value is X, and the previous was, I, then do something like, then do the subtraction. And I don't like this solution for the very same reason. Because if an update drops, again, I know this is very hypothetical, I am aware of that. But if an update drops, and updates do drop unexpectedly, updates to requirements, updates to rules that are embedded into the algorithm, if those change, you would have to go back and just update your code, which isn't something that's desirable. And as I said before, code that doesn't have to be maintained that often, it's just good. So yeah, I hope you enjoy this video. I hope you enjoy this explanation. Let me know. I'm gonna get rid of these examples here, not to skew the answer. So let me know in the comments below if you guys liked it. Also leave a like if you enjoyed this kind of content, and don't forget to subscribe and hit the bell and whatnot. Thank you for being here with me. See you in the next video. I'm making this way more awkward than it has to be, so just peace.